Hello everyone, Miss Katongo here. This is another physics related problem. But before we get into the problem that has been displayed on the screen, don't forget to like and subscribe to my YouTube channel. Let's get to it. The sinusoidal wave shown in figure P13.41 is traveling in the positive x direction and has a frequency of 18 Hz. Find the amplitude, wavelength, period, and the speed of the wave. The amplitude of a wave is said to be the maximum displacement of the wave. If we go into our diagram, we have the length of the wave from the trough to the crest being equal to 8.26 centimeters. And the amplitude of a wave begins from the rest to the maximum displacement of that very wave. So therefore, for us to obtain our amplitude A, we will have the distance, or rather this height, h divided by 2. 8.26 being the height, divided by 2, we'll have our amplitude being equal to 4.13 centimeter. And taking it to its standard units, we'll have 0.0413 meters in height. Getting to the wavelength is basically the distance between two crests. The distance between two crests. From this crest to that crest, it forms a wavelength. Therefore, for us to obtain our wavelength, we will multiply the distance of half of this very wave by 2. So hence, our wavelength being lambda is equal to 2 multiplied by the wavelength, half of the wavelength, which is 5.20 centimeter, and we'll have our result as 10.4 centimeter. Taking it to our standard units, we'll have our wavelength as 0.104 meters. Obtaining the period. The period is defined as the time taken for a wave to complete a cycle. And a period is obtained by taking the reciprocal of the frequency. And the frequency being given in this question is 18 Hz. So 1 over the frequency, which is 18, we'll have our period being equal to 0.056 seconds. And finally, the speed of the wave is equal to the frequency times the lambda, where we have our frequency being 18 Hz times our lambda being the wavelength obtained as 0.104 meters. We will have our speed as 1.872 meters per second.